on to closer to Earth stuff besides that. And these are, I have 2 different articles that talks about this, just so that we can find, I found some interesting things in each of them. Outrageous. Oh no, pi. No, this is something else. This is, we're closer to home. We're Earth's atmosphere. We're out of the theoretical. I would say that, but I'm trying to think if I accidentally didn't. Yeah. Anyways, uh, actually might be better if I put. Yeah. Anyways, NASA spots unexpected X-shaped structures in the Earth's upper atmosphere, and scientists are struggling to explain them. NASA's Gold mission found an unexpected X and C-shaped structures in the plasma of Earth's ionosphere. Researchers are likened our upper atmosphere to alphabet soup. Woo! A NASA satellite has spotted an unexpected X and C-shaped structures in the Earth's ionosphere, the layer of electrified gas in the planet's atmosphere that allows radio signals to travel over long distances. The ionosphere is an electrified region of the Earth's atmosphere that exists because the radiation from the sun strikes the atmosphere. Its density increases during the day as its as its molecules become electrically charged. That's because the sunlight causes the electrons to break off atoms and molecules, creating plasma that enables radio signals to travel over long distances. The ionosphere's density then falls at night, and that's where gold comes in, the mission. NASA's global scale observations of the limb and disk. Limited biscuit. I repeat, sometimes the names that they come up with, or also known as gold, mission is a geostationary satellite that has been measuring densities and temperatures in the Earth's ionosphere since its launch in October 2018. From its geostationary orbit above the Western Hemisphere, Gold was recently studying 2 dense crests of particles in the ionosphere, located north and south of the equator. As night falls, the low-density bubbles appear within these crests can interfere with radio and GPS signals. However, it's not just the wax and wane of sunshine that affects the ionosphere. The atmospheric layer is also sensitive to solar storms and huge volcanic eruptions, after which the crests can merge to form an X shape. In its new observations, Gold found that some of these familiar X shapes. I know, right? Well, not all science. I mean, I swear it's when they're making up mission names for space and stuff. They or anything like technology wise for space. They're gonna fucking make it work, even if it doesn't work. The acronyms are gonna work. Like they will literally different words within the acronym, or the actual name of the acronym. They will pretend does not exist to make the acronym work. In its new observation, Gold found that some of these familiar X shapes in the ionosphere, even though there weren't any kinds of solar or volcanic disturbances to create them, earlier reports of merging were only during geomagnetically disturbed conditions. Fazlu Lakshar, research science at the University of Colorado's Laboratory for Atmospheric and Space Physics, LAPS. In a statement, Lakshar is the lead author of the paper published in April in the Journal of Geophysicists Research and Physics. Yeah, it does make it. It works better, but some of them I'm like sitting here going, we're going to pretend that word doesn't exist there. Um, Or they take a letter that's not the beginning of the word to make up the acronym. I was sitting here going, that's not how acronyms actually work. I feel like I guess the more autistic part of me is like sitting there going, you gave me rules of how acronyms work and you are failing them. Please stop. You are being very loose with these rules of how acronyms work. I guess that's my more autistic side going, nah. This unexpected feature during magnetic quiet conditions. This suggests that what happens in the lower atmosphere actually affects the ionosphere more than extreme solar and volcanic events. Everything is a theory. It's true. In addition to the odd X's, gold also saw curved C-shaped bubbles appearing in the plasma, surprisingly close together. Scientists think they are shaped and oriented according to the direction of the winds. But gold imaged C-shape and reverse C-shape bubbles as close as 400 miles, or 643 kilometers apart. To have wind patterns change so drastically over short distances is quite unusual. You know, people say kilometers, and I say fuck that. It's kilometers for me. General statement. It's really important to find out why this is happening. Last research scientist Deepak Kuran, lead author of the separate paper published in November in the Journal of Geophysical Research Space Physics, said in a statement, if a vortex or a very strong shear in the plasma has happened, this will completely distort the plasma over a region. Signals will be lost completely with such a strong disturbance as this. If you're wondering why this problem is, you know, not just GPS. I mean, think of all the other stuff. Well, I mean, GPS on, you know, airplanes, but I mean, other stuff that's on airplanes, you know, radio connections, all this other stuff. If they can't do the GPS thing that they would rely on as a backup. Destroy the path. Signals will be lost completely with a strong disturbance like this. It's not the first time NASA has sought to understand more about the ionosphere. Most recently, a project called the Atmospheric Perturbations Around the Eclipse Path, APEP, investigated how the drop in sunlight and temperatures affects the Earth's upper atmosphere. During October 14th's annual solar eclipse around the southwest US, and then again during April 8th's total solar eclipse in North America, NASA launched 3 suborbital sounding rockets into the eclipse path to measure changes in electric and magnetic fields, density, and temperature within the ionosphere. The results of the mission are still forthcoming. And like I said, this is another version of this that kind of has closer looks of this. Okay, science. Revealed in the Earth's atmosphere, NASA scientists have discovered... Sounding gives me shivers. Well, I mean... I bet it more has to do with what, you know, the internet turned it into being. I mean, well, kink turned it into more than internet. NASA scientists have discovered something of an alphabet soup in the ionosphere that sits about 48 to 965 kilometers. Well, the thing is, what I remember before I found out about all that, what it could be, was I have a piano downstairs. And also has been really into, I mean, in the sense of, since I was young, doing music stuff. So having a sounding, you know, or a sounding tuner, is something that never in a million years would my mind immediately go to something sexual with it. And the findings could help improve space weather forecasts and radio communications. Shapes like this have been detected before, but the global scale observations of the limb and disk gold imaging instrument used here to give us our best look at them yet, revealing strange X and C shapes turning up at unexpected times and in some surprising places. Yeah. The ionosphere becomes electrically charged in the day as the sunlight strikes it, and then this creates plasma bands of charged particles that are further influenced by the Earth's magnetic field. Crests and bubbles of plasma form the shapes that have now been observed. Well, the X shapes observed. I know they say it's an X, but the first thing that goes through my mind is a DNA thing, but that's me. Previous studies have shown mergings of crests forming the X shape after solar storms and large volcanic eruptions, but the data in this new study reveals they can form in so-called quiet times, as well as hinting at more localized factors are involved. Computer models suggest lower atmospheric conditions could be pulling the plasma downwards. Like I said, this goes into some little other things. Earlier reports of merging were the only during geomagnetically disturbed conditions, says Fazlal Laksar, an ion sphere physicist at the University of Colorado. It's an unexpected feature during geomagnetic quiet conditions. Another finding that's puzzled scientists is the appearance of C and reverse C-shaped bubbles within the plasma. These shapes are thought to be created by winds on Earth, just as wind directions may shape how a tree leans. However, Gould has spotted these C's formations surprisingly close together, sometimes around 634 kilometers apart. Kilometers. Why am I now jumping over to kilometers? Kilometers apart, or 400 miles. Then again, and again, those point to more localized factors being involved, whether it's a weird windshield, a tornado, or something else. At the moment, the tight packing of C-shapes seems to be relatively rare, with only 2 observed by Gould so far. However, researchers are keen to investigate them further and find out what's causing them in the ionosphere. Within the close proximity, these 2 opposite-shaped plasma bubbles have never been thought of, never been imagined, says ionosphere physicist Deepak Karan from the University of Colorado. Plasma in the ionosphere is essential for radio waves being able to travel long distances, and discoveries in this field improve our understanding about how radio and GPS operate. Disruptions to the ionosphere, like those observed here, would have an impact on important communication and navigational infrastructure. This study and Gould data gives us another example of how improving technology and innovations in scientific research are helping us understand more about the Earth and the universe around it, even as they constantly change and evolve. The fact that we have very different shapes of bubbles this close together tells us that the dynamics of the atmosphere are more complex than we expected, said astrophysicist Jeffrey Kilsing from NASA's Goddard Space Flight Center, who wasn't directly involved in the study. The research has been published in the Journal of Geophysical Research Space Physics. Never before seen shapes up to 1,300 feet long discovered beneath Antarctic ice. The unusual patterns found beneath West Antarctic's Dos-Ton ice shelf could help scientists to better understand how glaciers erode. Scientists have discovered a never-before-seen patterns beneath a floating ice shelf in Antarctica, following an expedition to create the most detailed picture ever of the glacier's underside. The strange teardrop shapes were discovered below the Dos-Ton ice shelf in West Antarctica in 2022, when a remotely operated vehicle, ROV, drove 10 miles, or 17 kilometers, beneath this glacier and traveled more than 600 miles or 1,000 kilometers, along the other side of the ice. Researchers published the findings of its first of its kind survey Wednesday, July 31st, to the Journal of Science Advances. In order to understand the ice cycle in Antarctica and how ice gets from the continent to the ocean, we need to understand how it melts from beneath, a process that is equally important as calving from moving ice, land ice to the ocean. The study led by Anna Wallen, professor of oceanography at the University of Gothenburg, told Live Science, the Dodson ice shelf is a 30-mile wide or 50-kilometer chunk of floating ice 7 times the size of New York City, located on the coast of Marie Byrd Land in western Antarctica. It is part of the West Antarctic Sheet, which is dramatically calving glaciers that could cause sea levels to rise approximately 11 feet if they eventually drive the entire shelf to collapse. Steadily, erosion is nibbling away at the fringes of the ice shelf, with warming ocean waters infiltrating its undersides and underpinnings from the land, marking its eventual collapse inevitable, previous studies showed. To further investigate the processes threatening the 1,550-foot thick or 350-meter ice shelf, the researchers sent ROV below the ice to scan the glacier's underside with sonar, building up the most extensive and complete picture of the glacier's underside ever. These are the visualizations. Much as the scientists expect, the survey shows that the glacier is melting fastest at the point where underwater currents are eroding at its base. And fractures running through the glacier are helping to melt to travel up to the surface. But unexpectedly, they also discovered, instead of being smooth, the glacier's base was flecked with teardrop shapes emerging from the peaks and valleys in the ice. Some of these shapes are up to 1,300 feet long or 400 meters long. The researchers believe these weird patterns are created by uneven melting as water moves with the Earth's spin across the glacier's underside. If you look closely at the shapes, they are not symmetrical. They are bent a bit like blue mussels, and the reason for this asymmetry, excuse me, I know how to say it, asymmetry, is the Earth's rotation. Water moving on the Earth is subject to something called the Coriolis force, which is acting to the left of the direction of the motion of the southern hemisphere. If we are correct, there is a force balance in the layer closest to the ice, where the friction is balanced by the Coriolis force. The result is a spiral flow called an Ekman spiral, which is most commonly seen when winds travel over the surface water, but can also be created by water traveling over ice. Following the survey, the researchers returned with the ROV in January 2024, but the submersible got lost and disappeared beneath the ice shelf. Oh no, it went Titan. The team's next goal is to return with a new sub and continue surveying the uncharted depths beneath. It takes a lot of energy to melt ice, so all the ice in Antarctica is like a giant temperature stabilizer, an important part of the Earth's climate system. If the Antarctic sheet were to end up in the ocean at high rates, it could potentially influence sea level rise. So if we learn the upper and lower limits, we can also put limits on future sea rise level. Right, ready for some videos? Yellowstone Volcanic Observatory releases... yeah, it's aliens. No, it isn't. On July 23rd, 2024, a large hydrothermal explosion rocketed Biscuit Basin in Yellowstone National Park. The explosion came from Black Diamond Pool, launching rock fragments and water 400 feet in the air. There was no precursor detected by the monitoring instruments, and Biscuit Basin will remain closed as geologists assess the situation. I've got the update up here. Run! Run! But yeah.
Run.
Guys can't say run, but keep taking pictures of it. Run!
Run. She ran to the other side.
Grandma ran
Oh,
to the other
shit.
side, I think. So cool looking though. Anyways. Based on geologists' examinations, the debris from the explosion consists mostly of glacial materials, sandstones and siltstones, and gravels. No rhyolite bedrock, which sits about 175 feet under the surface, was present, indicating the explosion originated from a much shallower depth than that. The press release explains that this is not a surprise, as hydrothermal conduits in Yellowstone Park are mostly lower levels. It's still unclear how much of Biscuit Basin we'll see following the explosion. Shallow hydrothermal flow paths were clearly changed due to the explosion, but how well the thermal features will respond is unknown. It's possible that a placid hot spring will reform, but it's also possible that a new geyser could form. Further data will help explain. Okay. Here's the explosion was largely directed to the northeast towards Firehole River, away from the boardwalk, and the largest boulder, some measuring several feet across and weighing several hundred pounds, fell in that direction. This fortuitously directionality was probably the reason no one standing on the boardwalk at the time was injured. Yay! Hydrothermal explosions occur when liquid water boils and converts to steam in shallow subsurfaces. This sort of transition happens all the time in established geyser systems, like Old Faithful or Steamboat Geyser, where well-defined conduit systems allow that steam and hot liquid water to take an unobstructed path to the surface, resulting in a geyser eruption. But when the liquid-steam mixture is within a confined space that has become sealed and without that well-defined conduit system, pressure due to the expansion of the steam eventually overcomes the strength of the rocks and explosion occurs. In the case of the Black Diamond Pool in July 23 explosion was probably caused by the change in hot water reserved in the shallow subsurface. Silica precipitation can clog conduits or pipes in the reservoir, leading to accumulation of steam and pressure buildup. The data that geologists are collecting from the explosion debris will provide even more detail and exact conditions for the time.
What just happened at Biscuit Basin in Yellowstone National Park?
Well, that's another. Anyways, here's another one. Look at that picture, by the way. This is the damage. Luckily, nobody was in the way. Look at the damage. That's where people would have been. I mean, even if it wasn't like, you know, big rocks or whatever. I mean, it's steam. It could burn through your skin. Okay. In hydrothermal systems such as those in Yellowstone, waters often can be very close to boiling point. Think about that. It says Marianne Carpus, a professor of the geological sciences at the University of Texas in El Paso, who has studied geysers at Yellowstone. When there's a drop in pressure underground, it can cause basically the liquid to flash into steam. The steam takes up more space than the liquid in expansion, and when that happens, it can cause an explosion. Hydrothermal explosions have taken place in Yellowstone's Norris Geyser Basin in 1989, and Biscuit Basin. So Biscuit Basin has a few of these in 2009, and a smaller event was recorded in Norris Geyser Basin in April of this year as well. Despite the size of the explosion seen in the video, the parks and the USGS characterized it as a small one. The hydrothermal explosions can reach more than a mile high and leave craters a mile in diameter. Larger explosions happen every 700 years on average, according to the USGS. Carvas has said she knows the park has been trying to install more instruments in an attempt to detect similar events before they happen, but because of how dynamic geothermal systems are, these events are very hard to predict or hard to anticipate. So that's why in this case this morning, as well as 2009 and other times that this has happened, it's been a total surprise. All right, mysterious pink sands in Australia reveal hidden Antarctic mountains. Usually when something in nature turns pink, it's not a good sign. I don't know. Hey, to tell that to a lot of the plants. But weird pink sands was washing up on South Australian beaches have covered an ancient Antarctic mountain range thought to be buried under ice. When streaks of pink first appeared in the sands in Petrel Cove, a remote beach that meets the Southern Ocean, scientists in Australia quickly worked out what the colored sand was made of. A mineral called garnet, but were surprised by its age and where it originated from. This journey started with questioning why there was so much garnet on the beach in Petrel Cove, says University of Adelaide geologist Jacob Mulder. Is fascinating to think we were able to trace the tiny grains of sand on a beach in Australia to a previously undiscovered mountain belt under the Antarctic ice. The Earth's crust is constantly eroding and reforming, with loosened settlements whisked away on the wind and waters, getting deposited elsewhere to form new lands. If geologists are lucky, they can draw connections over huge distances. I know, right? Garnet on the beach sounds nice, though. A Final Fantasy IX beach episode! Come on, make it work! Let the suit of armor guy that my mind is having a moment with forget, because my mind is currently in a different box. Barrett. My mind's having a moment. A moment. My mind's having an absolute moment right now. Steiner. I'm quite sure there are quite not just fanfic, but actual, fan pictures, fan art. If geologists are lucky, they can draw connections over huge distances and long stretches of time between deposits of similar ages with alike properties. Garnet is a fairly common material, deep red in color. It crystallizes at high temperatures, usually where large mountain belts grind upwards out of colliding tectonic plates. This makes it arguably the most important mineral for deducing how and when mountains form, as the crystal's presence indicate the pressure and temperature history of the metamorphic rocks on which they form. The team's luteum and hafnium dating shows that some of the garnet found at the Petrel Cove and its nearby bedrock formations match the timing of local mountain forming events in South Australia. But their results indicated it most likely formed about 590 million years ago, some 76 to 100 million years before the Adeline fold belt took shape, and billions of years after the Calder Craton crustal block formed. The garnet is too young to have come from the Crawler Craton, and too old to have come from the eroding Adeline fold belt, explains Sheremine Verhart, a geologist graduate student in the University of Adelaide, Adelaide, who led the investigation. Instead, the garnet most likely formed at a time when South Australia crust was comparatively cool and non-mountainous. Mountainous. Garnet is typically destroyed by extended exposure to waves and currents, so the researchers also figured it was probably surfaced locally, even if it originally formed millions of miles away millions of years ago. Their investigations reveal a grand solution, one that links the pink sands of the Petrie Cove to layers of nearby glacial sedimentary rock with distant garnet deposits previously found in an outcrop of the Antarctic mountains in the East Antarctica. The rocky outcrops protrude from a thick ice sheet that otherwise completely conceals the underlying area, making it impossible to sample the geology beyond the exposed tips of a mountain range that is thought to lie beneath. The hidden mountain belt is thought to be about 590 million years old, just like the garnet analyzed in the study. The researchers haven't been able to get a good look at it. So I guess Australia and along there. Joining the dots with the ice flow indicators in South Australian glacial sedimentary rocks, Verhard and colleagues think that the garnet-rich glacial sands were ground out of the Antarctic mountains, which are yet to be seen the light of day, by an ice sheet moving northwest during the late Paleozoic Ice Age. When Australia and Antarctica were connected by a supercontinent, Gondwana, the garnet deposits were then locally stored in glacial sedimentary deposits along the southern Australian margin, explains University of Adelaide geologist, Stijn Gore. Until erosion once again liberated them and the waves and tides concentrated them on the South Australian beaches. An epic journey across land and time. So this, I guess, the Permio-Carbon-Oceus Bridge, I guess. No, wait, it's the dotted place, so it's right here. Ross Rogum. Origin. Oh. Protozoic basins, so that. Anyways. Alright. Godsmacking study finds life on Earth emerged 4.2 billion years ago. Once upon a time, the Earth was barren. Everything changed when somehow, out of chemistry available on the Earth's on our planet's history, somehow started squirming. Big Bang Theory joke. I mean, the song from Bare Naked Ladies. A process available matter to survive, to breed, and to thrive. That was something. What that something was when it first squirmed and have been burning questions to what that have puzzled humanity probably for as long as we've been able to ask, what am I? Now a new study has found some answers, and life emerged surprisingly early. By studying the genomes of organisms that are alive today, scientists have determined the last universal common ancestor, the first organism that spawned all life that existed today on Earth, emerged as early as 4.2 billion years ago. The Earth, for context, is around 4.5 billion years old. That means that life first emerged when the planet was still practically newborn. We did not expect the last universal common ancestor to be so old, just within hundreds of millions of years of the Earth's formation, says evolutionary biologist Sandra Avezcarinto of the University of Bristol in the UK. However, our results fit with the modern views on the habitability of early Earth. Back when it was new, the Earth was a very different place. Really? Who'd have thunk? With an atmosphere we would find extremely toxic today. Oxygen in the amount current life seems to need didn't emerge until relatively late in the planet's evolutionary history. Yeah, I know, right? That sounds about the same time that they were alive, and they still haven't gone. Still rule over us. Only as early about 3 billion years ago. But as life emerged prior to that, we have fossils of microbes from 3.48 billion years ago. And scientists think that conditions may have been stable enough to support life from around 4.3 billion years ago. But our planet is subject to erosion, geological, and organic processes that make evidence that life from around that time almost impossible to find. So, led by phylogeneticist Edmund Moody of the University of Bristol, a team of scientists went looking somewhere else, the genomes from living organisms and the fossil records. Their study is based on something called a molecular clock. Basically, we can estimate the rate at which mutations occur and count the number to determine how much time has passed since the organisms in question diverged from common ancestors. All organisms, from the humblest microbe to the mightiest fungus, have some things in common. There's a universal genetic code. The way that we make proteins is the same. There's an almost universal set of 20 amino acids that are all oriented the same way. And all living organisms use the adenosine triphosphate as a source of their energy in their cells. Moody and his colleagues worked out, based on these similarities and differences, how long it had been since the last universal common ancestor successors started to diverge. And using complex evolutionary modeling, they're able to learn more about the LUCA itself, which is what I just said about the last universal common ancestor, and what it was, and how it survived on Earth, so very inhospitable to its descendants. Luca, they found. I just realized Luca, the Pixar movie. I know that it wasn't supposed to be a common thing. I mean, connection thing, but it just popped in my mind. Luca, they found, was probably very similar to a prokaryote. Excuse me, a single-cell organism that doesn't have a nucleus. It obviously was not reliant on oxygen, since there would have been little oxygen available. It's also unexpected for a microbe. It's not unexpected for a microbe. As such, its metabolic processes probably produced acetate. Why is my mind having a moment? But there was something else interesting. Luca did not appears not to have been alone. Our study shows that Luca was a complex organism, not too different from the modern prokaryotes, says genomist David Ishnai of the University of Bristol. But it's really interesting that it is clear that it possessed an early immune system. Oh, so it had something I don't have. I mean, I have an immune system. It's not very good. Shows that even by 4.2 billion years ago, our ancestors were engaged in an arms race versus viruses. Because of its metabolic processes would have been produced waste products that could be used by other life forms, they could have emerged not long after the Luca did. This implies that it takes relatively little time for a full ecosystem to emerge in the evolutionary part of history part of a planet. A finding that has implications far beyond our own little pale blue dot. Our works draw together data and methods from multiple disciplines, revealing insights into early Earth and the life that could not be achieved by one discipline alone, explains paleobiologist Philip Donahue of the University of Bristol. It also demonstrates just how quickly an ecosystem was established on early Earth. This suggests that life may be flourishing on Earth-like biospheres elsewhere in the universe. Okay. I actually have pulled up the release thing of it too, so I have the abstract of it too. For this next one, dark oxygen discovered on the seafloor raises stakes for deep sea mining negotiation. The discovery of dark oxygen in the ocean's abyss is raising the stakes on negotiating over whether to mine the seafloor for battery materials and how to protect the sensitive marine life in the process. Rules for deep-sea mining have been at the heart of talks during the International Seabed Authority annual meetings in Kingston, Jamaica that ended Friday. A mining company that has already said that after the meeting ending, it would submit the first ever application to exploit minerals from the deep sea. The company's plan has triggered a race to get rules in place before any mining starts. But there is so little that humans know about the deep sea that growing chorus of science advocates and policymakers are sounding the alarm that there could be grave unforeseen consequences. Evidence of mysterious dark oxygen from the abyssal floor was published in a prestigious journal in July. Like I said, I have it pulled up there. And it raises new questions about the risks of mining that might pose to life at the bottom of the ocean sea that scientists are still trying to understand, and amplifying calls for a moratorium on mining. Today, we're at a crossroads. The decision made at this assembly will shape the future health and productivity of our oceans for generations to come. Palula President Sir Angel Whips Jr. said in his opening statement during the assembly, whether it is the undiscovered biodiversity that might unlock the cures for cancer, or the recent discovery last week of dark oxygen being produced in the deep ocean by the nodules of the ocean floor, we have so much to learn about the deep seabed and its vital roles it plays in our planet. What is dark oxygen? Oxygen is a product of photosynthesis. Plants and plankton use sunlight, water, and carbon dioxide to create sugars and oxygen. That's what makes the discovery of dark oxygen at the bottom of the abyss within depths between 9,842 to 21,325 feet, or 3,000 to 6,500 meters. So incredible. What's down there that can produce oxygen without sunlight? A paper published in the Journal of Nature Geoscience last week suggests that there's a completely different and previously unknown process for producing oxygen on Earth. And it comes from arguably the most unexpected places. The findings were so surprising that the authors themselves were initially skeptical of their own data. They'd set out to document how much oxygen deep sea organisms used up at the bottom of the Pacific Ocean. In an area between Hawaii and Mexico, the companies are eyeing for mining. Of course they are. They sent landers down some 13,000 feet, or 4,000 meters, to take measurements in spaces closed off to the outside currents that would typically bring oxygen from the surface of the sea floor. From the surface of the sea. The method is sort of like placing a can upside down on the bottom of a pool and documenting what happens inside. They expected to see oxygen levels drop over the time in the enclosed area, but they actually documented the opposite. Thinking something must be wrong with their sensors, they swapped out equipment and yet kept getting similar readings. When they lifted those landers up, oxygen bubbled out. This is Pilomedic. They just still don't know for sure how oxygen is produced, but they have a hypothesis. Polymetallic metallic nodes rich in nickel, copper, cobalt, iron, and manganese are strewn across the seafloor. Exactly what mining companies are interested to exploiting, and has even described as batteries in a rock. They just might be able to produce enough of an electrical charge to split seawater, releasing oxygen through electrolysis. There's a lot more researching to be done on this hypothesis. The authors of the paper were taking oxygen readings and weren't looking for higher levels of hydrogen, which you can expect to see if these rock batteries are actually capable of splitting water. They brought up some of the nodules up to land to see if they could replicate the process in a lab. That's how they were able to rule out other possibilities, like microbes producing dark oxygen. Again, the results were surprising. I have approached the problem from a perspective of, there's no way these things have this high voltage, and the readings were off the charts. No wonder why the, companies want them. Says Franz Geiger, one of the authors of the paper and professor of physical chemistry in Northwestern University. The team documented voltages as high as around 950 millivolts, just shy of 1.3 to 1.5 volts, that would be needed to split seawater or at least get oxygen-producing half reaction, called an oxygen evolution reaction. Out in the ocean where there are vast networks of nodules, the voltage might get high enough to trigger those reactions, they hypothesized. The research was funded in part by the Metals Company, the same company planning to apply for a license to start deep-sea mining. The company says it's conducting one of the most comprehensive deep-sea research programs in the history, and is spending more than $200 million in environmental assessments. But now they're disputing the findings, picking a fight with the researchers whose findings may not jive, of course. Hey, how are you? Yeah. But yeah, that's what I wanted on that part. Unless we want to go into the politics of it. Do you want to keep reading about the politics of deep sea mining? I just wanted to. Well, I guess going through and showing what the company is arguing might be. When The Verge reached out to the company it pointed out to a statement it released saying that they were surprised to see the questionable paper published. The company says it's still prepared. Anyways, yeah. Hi, Apocalypse. I'm not sure I said hi. No, the chat is cute. The chat is cute. The company says it's still preparing the comprehensive rebuttal, but so far questioning the research's flawed methods, in part because the data was collected under conditions not representative of the seafloor area where it's interested in mining. It also says that the paper contradicts other studies and was rejected by other journals. The research team stands by its works. We were the worst critics of this paper for a long time. For 8 years, I discarded the data showing oxygen production, thinking my sensors were faulty. Once we realized something may be going on, we tried to disprove it, but in the end, we simply couldn't. Lead author Andrew Sweetman, a professor of the Scottish Association for Maritime Science, says in his own statement. But yeah. Basically, the company's mad that the scientists found something. But this is the actual Nature Geoscience thing. You see Andrew Sweetman. This is the abstract. Deep floor organisms consume oxygen, which can be measured by in situ benthic chamber experiments. Here, we reported such experiments at the polymetallic node-covered abyssal floor in the Pacific Ocean, in which oxygen increased over 2 days to more than 3 times the background concentration, from which the exo-pseudo incubations we attributed to the polymetallic nodes. Given the high voltage potentials, up to 0.95 V on nodal surfaces, we hypothesized that the seawater electrolysis may contribute to this dark oxygen production. So basically, like I said, without any light, they produce oxygen. And this is the oxygen 2 is prevalent in the deep sea surface sediments, where its rate of consumption reflects the sum of aerobic respiration and oxidation of reduced inorganic components produced by anaerobic decay. And then it goes through more, lots of science talk that we were mentioning earlier, and these are the charts. And peer review. Further, okay. Remains neutral. Anyways, on to other things. Trail camera captures the first of its kind footage of one of the rarest feline species in the world. It was the first time a mother and 2 offsprings have been recorded. No, yeah, he's so cute. A rare sight from the deep in the forest of Borneo has given conservationists hope that the vulnerable clouded leopard is on the prowl. It's so pretty. In April, the Orangutan Foundation and the Puting National Park captured a video of a mother and her 2 cubs hopping through a thicket. One of the cubs even stopped to take a long look at the camera. So cute! Sorry. Ooh, cute, pretty. Camera research. Clouded record recorded a few times in the national park, but this is the first time we actually seen a mother and 2 offspring. For the population to be reproducing is an incredibly encouraging sign. Clouded leopards have a low recruitment rate, meaning that less adults than expected produce and raise offspring, which live long enough to join the breeding population at 2 years old. It's so pretty. The Borneo clouded leopard is on the International Union for Conservation of Nature Red List of threatened species, according to the foundation. The animal is endangered partly because of its low recruitment rate, like I mentioned before. Deforestation is also taking a toll on the leopard, which relies on forests for habitation. The foundation says in a news release that more than 2/3 of the animals have been killed in recent years. On Instagram, noted the first time that the mother and 2 offsprings have been recorded. For a population to be reproducing is an encouraging sign. All right, here's on to one of the things that's named in the title of the stream. These ants perform life-saving operations on injured nestmates, similar to humans. Last year, an ant species was caught using antibiotics. Now another has been observed performing amputations. Researchers have just confirmed with experiments that the surgery and the other treatments ants provide each other do indeed save the ants' lives. While we have known for a few years now that ants treat each other's wounds, we've only just learned how astonishingly complex and precise ant medicinal care can be. Ants are able to diagnose a wound, see if it's infected or sterile, and treat it accordingly over long periods of time by other individuals, explains behavioral ecologist Eric Frank from the University of Würzburg in Germany. The only medical system that can rival would be the human one. Florida carpenter ant tending nestmates wounds. Frank and colleagues analyzed leg injuries in Florida carpenter ants, Campus floridanus, when the wounds in the shin-like tibia were left unattended. For only 15% of the ants survived. Not America. Yeah, I know, right? But if nestmates were allowed to attend to the wounds, an injured ant's survival rates increased to an incredible 75%. The tibia wounds were treated with mouth cleaning, in which the treating ant held the delicate injured limb with its mandibles and front legs, licking the wound for extended periods. Let's see. I guess that's that right there. Of course, it has a mark on it. Oh no, ants everywhere. Oh no. But when carpenter ants encountered nestmates with injuries on which would be equivalent to our thighs, tiny surgeons first cleaned the wound before amputating the leg. This involves repeatedly biting the injured limb until it was severed. The survival rate increased from 40% for ants with untreated femur wounds to about 90% after amputation. And here's the 4 steps of an ant leg amputation surgery: licking the original wound, biting at the leg at the trochanter, removing the amputated segment, and licking the amputated wound. Yet the ants never amputated legs with wounds near the tibia. So Frank and team experimentally, nothing cruel about this, you know, mad scientists. I mean, gonna cuff your leg, or like cause a wound on your leg, yeah. So teams experimentally amputated the tibia injured ant limbs to find these ants' survival did not increase. In tibia injuries, the flow of the hemiolimb was less impeded, meaning the bacteria could enter the body faster. While in femur injuries, the speed of blood circulation in the leg was slowed down, says Frank. It takes ants 40 minutes to complete a surgical amputation on a nestmate's leg. Being a doctor. Yeah, of course not. Thus, because they are unable to cut the leg off sufficiently quickly to prevent spread of harmful bacteria, ants try and limit the probability of lethal infection by spending more time cleaning the tibia wound, explains evolutionary biologist Lauren Keller from the University of Lausanne, Switzerland. Infections are a major threat to animals, particularly, say, isn't there a actor guy that, I mean, not recently, but I mean, kind of recently, like, some of his texts were talking about eating, like, cannibalism, all this other stuff, and that was a part of his kinky thing. And the got, of course, yeah, some of the things he wrote was just amazing. Bose versus the World, I think is where it was on. That somebody watched it, watched the Piers Morgan thing, where he's being roasted by Piers Morgan. It was an actor, no longer an actor, by the way. Obviously, after some of those texts were revealed, I mean, he didn't do it, but the stuff that he wrote about, you know, making. I don't even know what to say to it. Infections are a major threat to animals, particularly in social species where the risk of transmission is increased by close quarter living. Insects are known to migrate some of these risks by destroying infected broods or leaving the nest to die in isolation. Medical care of nestmates is likely another of these strategies, but how it arose in ants is an intriguing question, given there's little evidence they can learn. This suggests that such behavior may be innate, despite its complexity, the researchers suspect, but they're also keen to experiment further to find out. If you look at the videos where you have the ant presenting the injured leg and letting the other one bite it off completely voluntarily, then present a newly made wound so another one can finish the cleaning process, this level of innate cooperation to me is quite striking, says Frank. All right. My voice is kind of going. 1 second. Butterflies can make epic Atlantic Ocean voyages, shocking scientists. Some butterflies may be able to journey across entire oceans with the help of the wind. A world-first study has now shown that the painted lady butterfly, the Vanessa cardii, can cross the world's second largest ocean, the Atlantic, covering 4,200 kilometers, or 2,610 miles, in as few as 5 to 8 days. The trip, researchers claim, is among the longest documented for an individual insects, and potentially the first verified transatlantic crossing. The incredible discovery was made after more than a decade of mystery. It all started in 2013, when a flock of fatigued butterflies landed on the beaches of French Guiana with torn and tattered wings. The entomologist Gerard Tavel-Vera, who found the insects resting on the sand early one October morning, was shocked. These were painted lady butterflies, a common species with a stable population found on every continent except for Antarctica and South America. For years, Talavera was left wondering, how did these insects get to South America, and where did they come from? At last he has an answer. Analyzing the DNA of pollen left on the butterflies, Taviera and his colleagues at the Botanical Institute of Barcelona have shown that this lost flock probably flew in from sub-Saharan Africa after undertaking an accidental transatlantic trip. It seems that adult insects were caught up in a strong trade wind in 2013 and were blown 4,200 kilometers off course. Judging by the trade winds that year, the trip would have taken the butterflies around 5 to 8 days. With nowhere to land, the insects would have used their wings sparingly. Without the help of powerful winds, researchers theorized that the flock would have gotten only about 780 kilometers before eating through all their energy and perishing. Our findings suggest that we may be underestimating the transoceanic dispersal in insects and highlight the importance of aerial highways connecting continents by trade winds, writes Talavera and his colleagues. The monarch butterfly, the Danaus plexippus, is world famous for its nearly 5,000 kilometer long migration, which makes each year from North America to Mexico. But painted lady butterflies also undertake a long-distance trip between Europe and Africa each year. Some studies suggest a single generation can migrate more than 4,000 kilometers. That would make the butterfly with the longest lifetime migration. But unlike other animals that travel through the air, like birds, it's a lot harder to track the global movements of little creatures like insects. The wings of the painted lady butterflies in French Guiana were found to contain isotopes that suggest they were born in Western Europe. This means the flock may have traveled more than 7,000 kilometers in one lifetime, visiting no less than 3 continents. It is the first time this combination of molecular techniques, including isotope geolocation and pollen meta barcoding is tested in a migratory insects, says geochemist Clemette Beltale from the University of Ottawa in Canada. The results are very promising and transferable to many other migratory insect species. The technique should fundamentally transform our understanding of insect migration. And while long-distance migration from Europe to Africa or North America to Central America is undoubtedly impressive, there are also plenty of places for butterflies to stop in between and refuel. An ocean crossing is a whole other challenge. Painted ladies may only have the wing size of a pinky finger and the brain size of a pinhead, but they are incredible flyers. In fact, their tiny size gives them an advantage. It allows the species to glide on the winds, sometimes going as fast as 4 to 8 kilometers or 30 miles an hour. It would be scary to have that coming at you. And it's not just these lowly insects that scientists are underestimating either. The winds that blow across the Atlantic from the Sahara to the tropical Caribbean are also stronger than experts once thought, capable of carrying large particles of dust as far as 3,500 kilometers. It makes sense that a small winged creature could make it pretty far gliding on these winds with minimal flapping effort. We usually see butterflies as symbols of the fertility of beauty, but science shows that they can perform incredible feats, says etymologist Roger Vela from CSIC Pompeu Fabra University in Spain. There's still so much to discover about their capabilities. All right. I probably should have moved this to a different part. Almost done. My voice is going. The story of Greenland keeps getting Greenland fossils discovers stunned scientists and confirms that the center of the ice sheet melted in recent past. The story of Greenland keeps getting greener and scarier. A new study proves that the first direct evidence the center, not just the edges of Greenland's ice sheet, melted away in recent geological past, and the now ice-covered island was then home to a green tundra landscape. So it actually was Greenland. A team of scientists re-examined a few inches of sediment from the bottom of 2 mile deep core extracted from the very center of Greenland in 1993 and held in for 30 years in a Colorado storage facility. They were amazed to discover the soil contained willow wood, insect parts, fungi, and a poppy seed in pristine condition. I'm going to throw this out there. If I remember correctly, the reason why Greenland was named Greenland was to invite people to come live there. More or less to trick people to think that the land was green if that's where they were entering. The reason why Iceland was called Iceland was to keep people the fuck away. These fossils are beautiful. I guess that's the stuff. Says Paul Bierman, a scientist at the University of Vermont, who co-led the new study with UVM graduate Haley Mastro and 9 other researchers. But yes, we go from bad to worse in what this implies about the impact of human-caused climate change on the melting of Greenland's ice sheets. The study published in the Proceedings of the National Academy of Sciences on August 5th confirms that Greenland's ice melted and the island green during a prior warm period, likely within the last million years, suggesting that the giant ice sheet is more fragile than scientists have realized until the last few years. If the ice covering the center of the island was melted, then most of the rest of it had been melted too, and probably for many thousands of years, Bierman said, enough for soil to form and an ecosystem to take root. This new study confirms that and extends that a lot of the sea level rise occurred at a time when the causes of warming were not especially extreme, says Richard Alley, a leading climate science at the Penn State, who reviewed the new research providing a warning of what damages we could cause if we continue to warm the climate. Sea level today is rising more than an inch each decade, and it's getting faster and faster. It's likely to be several feet higher by the end of the century, when today's children are grandparents. And if the release of greenhouse gases from burning fossil fuels is not radically reduced, he said, the near complete melting of Greenland's ice over the next centuries to a few millennia will lead to 23 feet of sea level rise. Look at Boston, New York, Miami, Mumbai, or pick your coastal city around the world and add 20 plus feet of sea level. It goes underwater. Don't buy a beach house. Wasn't planning on it either. Core assumptions. In 2016, Georg Schaffer at the Columbia University and colleagues tested rock from the bottom of the same 1993 ice core called GISP2 and published a then controversial study suggesting that the current Greenland ice sheet could be no more than 1.1 million years old, and that there were extended ice-free periods during the Pleistocene, the geologic period that began 2.7 million years ago, and that if the ice sheet was melted at the GISP2 site, then 90% of the rest of the Greenland would be melted also. This is a major step towards overturning the long-standing history that Greenland is an implacable fortress of ice, frozen solid for millions of years. Then, in 2019, I guess the University of Vermont, Paul Biermans and an international team re-examined another ice core, this one extracted at Camp Century near the coast of Greenland in the 1960s. They were stunned to discover twigs, seeds, and insect parts at the bottom of the core, revealing that the ice there had melted within the last 416,000 years. In other words, the walls of Ice Fortress had failed so much more recently than had been previously imagined. Once we made the discovery at Camp Century, we thought, hey, what's at the bottom of GISP2, said Berryman, professor at the UVM's Rubinstein School of Environment and Natural Resources and fellow in the Gunn Institute of Environment. Though the ice and rock in that core has been studied extensively, no one's looked at the 3 inches of till to see if it's soil and if it's contained plant or insects remains, he said. So his colleagues requested a sample from the bottom of the core held at the National Science Foundation of Ice Core faculty in Lakewood, Colorado. Now this new study in PNAS provides confirmation that the 2016 fragile Greenland hypothesis was right, and it deepens the reasons for concern, showing that the island was warm enough for long enough that an entire tundra ecosystem, perhaps stunted trees, established itself where today is ice 2 miles deep. Now we have direct evidence that not only was the ice gone, but the plants and insects were living there. That's unassailable. You don't have to rely on calculations or models. The initial discovery that there was intact biological material, not just gravel and rock, at the bottom of the ice core was made by geoscientist Andrew Christ, who completed his PhD working at UVM and was a postdoctoral associate at Bierman's lab. Then Haley Mastro picked up the case and began to study the material closely. It was amazing, she said. Under the microscope, what had looked like no more than specks of floating on the surface of a melted core sample was in fact a window into a tundra landscape. Working with Dorothy Petit, an expert in macrofossils at the Lamont Doherty Earth Observatory and co-author of the new study, Mastro was able to identify the spores from spike moss, the bud scale of a young willow, the compound eye of an insect, and then we found an Arctic poppy, just one seed of that. She said, it's a tiny flower that's really good at adapting to the cold. That's not good. It lets us know that Greenland's ice melted. There was soil because poppies do not grow on top of miles of ice.